So my buddy Jacob said, hey, we should test fit a headlight, make sure it's going to fit. So I kind of put this up in here and got it roughly lined up. And he was worried about it hitting the air filter. And I was like, look, we got plenty of clearance. I mean, look at this. We got, I don't have my feeler gauges, but you know, that's at least 20, 30 thousandths. I don't know what he was worried about. Hey guys, welcome back. So we decided we're going to build this fan shroud the way we talked about. So the first thing we got to do is we got to get accurate dimensions from the heat exchanger, and we need accurate dimensions on the fan, and then we can put both of those in our 3D modeling software and then develop a shroud that fits the two, and that way we know that what we build on the shroud will fit these components. So my buddy Jacob here is going to help me build this, and what we did, we laid this heat exchanger out on a bench. We got ourselves a rule, we got ourselves a tape measure, we have a caliper, we'll go get it, and just a piece of paper and a pencil. We already started. As you can see here, we got like the basic outline of the core of itself, and if you notice, we had trimmed this top flange previously, so we don't have the full flange there, whereas on the bottom here, we do have the full flange. So we're going to document the dimensions that we have. I think we can make this work. We'll just have to drill some extra holes in this section, but it should be big enough to do that. So we're gonna get our critical dimensions, which is basically just the core, the flanges, and then we're gonna also model the fittings and the thickness of the core. That'll pretty much sum it up for the heat exchanger. And then on the fan, so we don't need to worry about all this, but we'll get this outside dimensions, we'll get the center to center on all the holes for the bolt pattern, the general thickness, you know, just the kind of the rough outside dimensions, and that's about it. So I'll show you that progress as it develops. Alright guys, well, here's some of our dimensions. Jacob's finishing up the measurements. I'll show you what we got. He's measuring these fittings right here. We'll have that shortly. But you can see we drew our flange down here, and we picked up all our holes using a caliper, got our dimensions. And you can see some of these are common numbers like 0.9, 5.5. So that kind of gave us confidence that we got this right. But we did measure it with a caliper. So we got those dimensions. And the flange up here is basically a mirror image, but we had cut that one short, so we included only the relevant ones. So the total flange was 0.55, but there's a little radius where they bent the metal, and so the flat portion is only 0.4 inches on that one. And then you can see we lost about 0.15 due to the radius. So this one down here, we also are going to have lost 0.15. I should probably make a note that that's true. And that gives us the rough dimensions for the heat exchanger. We still got to pick up the thickness as well, and then we'll put the fitting dimensions, and that'll be it for the heat exchanger. Alright, so we finally got the rest of these dimensions. So we captured this hex, which is, it's actually just one inch on the flats. And I'll show you, we got all the flange dimensions here, but look, we got 2 more pages. So here the core, we captured the core thickness of 1.5 inches, and we picked up our flange as 50 thou. Oh, we forgot to measure how thick the flange is, but it's 50 thou away from that surface. And then we got the center distance from the core to the center of the fittings. And then lastly, we noticed the core. So if you look at the side profile, it actually has like this weird geometry going on the edges. It's not square. And it's kind of hard to see, but they actually put a radius and then a 45. So we ended up capturing those dimensions as well. So this is from the center of the core. You can see we've got our little radius. Well, we don't know what the radius is, but we know it exists, and we know it stops at this dimension. And then this 45, probably should have put that that's a 45. But that continues, and then we know what the flat is. So we kind of measured the things we could, and then we'll figure the rest out in CAD. But yeah, that's I guess we'll grab the flange thickness there of the sheet metal, and I think that'll do it for the dimensions on our heat exchanger. So we're getting ready to pull our measurements for this fan, and we actually looked on the box. The box actually does have a few dimensions, but they only have these 3: length, width, and depth. That's really it. We need the center to center on all the holes. And here's the thing, it's kind of hard to measure. So if we flip this over, you can kind of try to measure, but you don't really have a reference. So here's what we're going to do. We're just going to take this old box and cut a flat piece of this and lay the fan on it. And without moving it, we'll use a Sharpie or a pencil, and we'll draw the center of each circle. And then from there, we can remove the fan and put a tape measure or a caliper or something directly on the cardboard and pull our measurements that way. So hopefully that speeds this up some. Alright, so we just threw the fan on here and drug a pencil around it, and here's what we got. Now we've got all of our dimensions on a flat sheet of cardboard, and We may need a bigger ruler, but now it's as easy as just creating a datum and taking measurements. We also drew the circle, so that's roughly the dead spot in this fan. So if you look at the fan, you'll see it's got blades, but there's this huge dead spot where the motor and fan blades connect, where there's no airflow, which is when you build a shroud, you're trying to fix that. You're trying to get air to flow in this portion, and you also, so our heat exchangers like up here, you know? So this corner would get left out, and so our fan shroud, we're basically feeding airflow to this portion of the heat exchanger on all four corners, and also feeding air to the center. So we get more even airflow and hopefully more heat transfer, for a more effective heat exchanger. Alright, so we needed a datum to have a center to work off of, so what we did was we just drew a straight line in our circle from, like, say, here to here, there to there, and what happens is as the lines intersect, that shows you where the center is. So you can see it's easy to see now. Now the next thing, now that we know where the center is, I want to draw an XY coordinate system on here. So if you back up a little, we see we got a little carpenter's square. And all we did was, there's a flat down here on the fan. So we just took our square, try to do this, but roughly speaking, we just took our square and lined it up off that flat and then extended that line that way. And once we had that, we used that line squared over here to draw our y-axis. And now that we have our y-axis, we're going to come up here, line up on our y, and draw our x. So we're about to do that now, and then we'll extend it this way, and at that point we'll have an XY coordinate system at the center of the part to take all our measurements from. Alright, so we finished drawing our x-axis, and now we've got a XY that intersects the part. Now we'll start taking our measurements. Alright, so I'll show you how we're doing this. We're trying to get the XY coordinates of that hole relative to our datum. So what I did was I took a square and I lined this up on our y-axis. So you can see that line there lines right up with our square. And then it comes across at that angle and intersects that point of the center of that circle. And then we just drew a dashed line across. So I'll shift this a little and you can see. That's how we created that line. And now that we've done that, once I get this equipment out of the way, I can just come in here with a caliper and measure that. And that'll tell me the y dimension of that circle relative to our datum. We can do the same thing here, and that'll tell us our x dimension relative to the datum. And that's it. Pretty simple. That gives us the XY coordinates with pretty high accuracy. And we're about to do this on the other side, but I'm going to guess that this is all a mirror image. So this hole here will be mirrored across this axis to this side, and then both of these holes will mirror across this axis. We're going to check real quick, but I'm pretty certain that'll be the case. So really, we'll just have to do that one, and we'll have the dimensions for all of them. On both sides. Alright, so we got our dimensions for the one on the left. You can see we got our drawing lines drew on the right. And now, if I can do this one-handed, we're going to measure this with a caliper and see what we're looking at. So we'll put this jaw right on the center of that hole. Sorry, this is about like that. And we'll move our outer jaw. Try to hit this line. There we go. There we go. We're pretty much at 5.7 inches. Now we're going to shift over to the other one. That is not 5.7. Well, we'll check our stuff. Maybe our datum's off a little bit. Alright guys, well, it turns out we did get the datum wrong. You'll see in the next episode we're going to get that fixed and finish this up. But that's it for today, so y'all feel free to hit the like button, leave a comment, tell me what you think. Coming up in the next episode, we're going to get these drawings finished up, and we're actually going to fire up the CAD software, and I'll show you how we model this. Alright, y'all take it easy.